All right, so good afternoon, everybody. I was going to start us off with looking at this ready to learn stuff and like, hey, what's going on here? And finding different equations here. So this is hopefully to help you with some of the Alex stuff and get us into working with this stuff so you'll have a slightly easier time of finishing off this week here. Okay. So I'm just going to hit this and see what kind of equation, what kind of thing it gives me. And I understand these are a little bit on they're a little confusing. Okay. So right here, usually the kinds of equations that you solved in like say Algebra 1 in high school, going back to that, or in some of the other classes, they're called conditionals. Okay. So if I do something like a 5x minus 4 is equal to 0, and we solve this, right? We're going to add 4 to both sides here. So I'm getting the 5x. Let me just do this in turn here. 5x is equal to 4, and then we're going to multiply both sides by 1/5, or divide by 5, either way. But that'll cancel, right? And we'll get x is equal to 4/5. This kind of equation is called a conditional. Okay, it's true when x happens to be 4/5. Okay, you plug 4/5 in here and we get a true statement. Okay, there are equations that are never true. Okay, if we do something like, it's hard to come up with something that is just blatantly false. But if you get an equation and the answer turns into something like that, okay, 0 equals 1, this is always false. Okay, so this is never true. This is just simply, it says no solutions. Okay, it's always false. Like if we do a 1 over, say, x minus 3 is equal to 0, the first thing you want to do is you want to multiply both sides by x minus 3 in order to clear the fraction. Those cancel, right? And then 0 times this is just going to be 0 still, and we get 1 is equal to 0. So this is a no solution. Okay, it's always false. There's just never going to be, right? There's never going to be a solution of this equation. And then we have tautologies. We have equations that are always true. So you're going to end up at the end, you're going to end up with something like that. Okay, 1 is always equal to 1. So that's the way that works. So this has infinitely many solutions. An equation that would lead you to this would be infinitely many. Something ridiculous like that. You have infinitely many solutions, right? A number is always equal to itself, so we don't have to worry about that, okay? But it can come up. They hide it, right, in these little pieces here. But that's what we're going to end up with, all real solutions or no solution or some kind of conditional. Well, when this is the value, then it's working, okay? So that's what's going on. That's when they say we have 3 possibilities, okay? You either have, it never works, it works once, or it works for a number of things. Okay, so if I just go through this and kind of, let's just walk through doing a couple of these to see. Okay, so we have -3. We have u plus 4 minus 2u is equal to 2. U plus 1. Okay, that's a 2. All right, so the first thing we're going to do is we got to unravel this, right? We got to distribute this. So we have -3u minus 12 minus 2u, right? And that is equal to 2u plus 1, okay? So we can combine our terms, right? You're $3 in debt, you spend another $2. Now we are $5 in debt, minus 12, and that is equal to 2u plus 1. Okay, so the first thing to do is untangle this knot. Then we can reassess. Okay, we're going to go ahead and subtract another 2 u's. And we're going to go ahead and add 12. We're going to go ahead and add 12. So here we're going to have minus 7u, right? Minus 5 minus 2 more equals 13. And then we can divide both sides by minus 7 and get u is equal to 13/7. Just so you know that those are all equivalent. Okay, all of these are the same thing. I want to say equals. Okay, or 13/-7. Okay, all of these things are the same number. Okay, so yeah, this one, it's conditional. It's true when u happens to be this number. Okay, so in this case, we have one solution. Oh, it's not going to let me do anything because it's an example one. Okay, that's fun. So the second one here, 3y minus 2 minus 5 is equal to minus 2y minus 2, and in parentheses, y plus 3. Okay, so what do we have here? We have 3y minus 3 times 2 is 6. Okay, oh, that's a 5y. All right, and that is equal to minus 2y minus 6. 3 minus 5, right? I have $3. I spent 5 of them. I'm now in debt. And at this point, you might be thinking, I see something that's rather suspicious here, right? We add the two y's and they cancel, and we end up getting -6 is equal to -6. That's true. Okay, that's always true. So no matter what y is, this is always going to give us a true statement. We don't care what value you plug in here. It's always going to be true. So we go ahead and click all real numbers are solutions. Okay, so that's the kind of thing that they're showing. Let's see if we can do another one. Let's see, that's going to be 5x and 4x, and that'll be that. That'll be 10. Okay, this will work. Okay, I think this one, we can do both. That's fine. Okay, so we have 4u plus 1 plus u is equal to 3. U minus 2 plus 2. Yep. All right. So again, distributing. So we have 4u plus 4 plus u is equal to 3u minus 6 plus 2. Okay. So u plus 4u plus 1u is equal to 5u's plus 4. Okay. So it's kind of like we have dollars and euros here, right? I have $5 and 4 euros. So like, what are you going to have? I'm like, I've got $5 and 4 euros. If you don't have a bank, you're stuck with that. Okay. So we have 3 u's and then minus 4, right? Minus $6. $6 in debt, you pay back 2. Like, I'm sorry, you're still in debt here. And then we're going to go ahead and subtract 3 u's from both sides. And we'll get 2u plus 4 is equal to -4. So I subtract 4 from both sides. Right? We have 2u equals -8. Sometimes this ends up to being 0 on the right-hand side, and that's okay. 0 is a number. So u is equal to -8/2. That's going to give me -4. Okay, so again, a conditional. All right. If we go next one, we have plus minus x. Is this equal to 10 plus 4 x's plus 1? All right. So if I go through and do this, we have 10. Right? Tell you what. No, that works. That works. So 10 plus 5x minus x, and that's equal to 10 plus 4x plus 4. Okay, so combining our terms, we have 10 plus 4x. If you want to write 4x plus 10, that's fine. Okay, and we have 4x and 4 would make 14. When we subtract our 4x's, right, we subtract our 4x's, then the values we end up with is 10 is equal to 14, and we know that that's never true. Okay, so that would be no solution here. There's no values of x that are ever going to make this thing true. Okay, even if I plug in 0, it's just not going to matter. Okay, because we'll have 10 is equal to 14 if I set x equal to 0. And if I set x equal to any other number, we're still going to get this kind of nonsense. All right, so That's the kind of thing that we have for that. Okay, so that's what they're talking about. Let's see. Can I go backwards? I don't know if I can. Nope, I don't think I can. All right, so let's see what we have here. We have finding solution to, okay, so we have a solution to two variables, equation with two variables. So let's see what that's going to look like. Okay. Really? That's okay. I thought they were talking about something that was a little bit more complicated, but that's okay. We can start here. So what we want to know here, right? 2x minus y is equal to 9. Now, I think the easiest way to do this, I mean, this one we kind of just guess a couple of numbers and it'll work. But what happens when this gets to be more complicated? Okay, so I would rather write this as y equals some stuff. Okay, and then plug in numbers that way, because it's a lot easier for me to think that way because we've been doing math that way for a long time. Okay, so what I'm going to do here is I'm going to add y to both sides. So we have 2x is equal to 9 plus y. And then I'm going to put the 9 on the other side, subtract 9, and we're going to have 2x minus 9 is equal to y, or we could write this backwards. Y is equal to 2x minus 9. Now, all we're going to do is we're going to plug in an x, and we're going to get a value out for y, and those will be an ordered pair that would allow this to be a solution. Okay, so let's go with x is equal to 9 halves. Okay, why'd you pick that? Like, let's find out. And you could have picked x equals 0. That's fine. Okay, that is absolutely fine. So we have y is equal to 2. Sorry for my heater there. Minus 9. Those cancel, right? So y is equal to 9 minus 9. 9 minus 9 is equal to 0. So the 2 points that I have happened to here, we have 9 halves and 0. Plug that in. What if I decided to go the other way around? What if I said, let's just let x equal 0. So y is equal to 2 times 0 minus 9. So y is equal to minus 9. When I plug that back into my original here, right? 2 times 0 minus, what's y? Negative 9 equals 9. 9 equals 9. Okay. So that's all they're wanting us to do for this one. Like I said, I like to solve it for y equals, make it look like a line. So we'd have y equals mx plus b first, and then we can go through and do something else. But it's not quite that necessary to do that. It's just I find it to be easier to think about it that way. All right. So hold on for just a moment here. I am going to go. I'm going to check something. I think we're going to go back to. I think. Well, let's do 2 more of these things. Okay. So solving an equation to find the value. Let's see what do they mean by that? Okay. Find the value of 6v minus or plus 1, given that 7v plus 1 is equal to 8. Okay. So sometimes there's kind of cutesy ways to do this. In this case, I don't think there's really a nice cutesy way here. 7v plus 1 is equal to 8, and 6v plus 1 is unknown. Okay. So can we go ahead and solve this thing? Can I go ahead and say, well, let's subtract 1 from both sides? So 7v is equal to 7. And that would be v is equal to, right, we're going to divide both sides by 7. And that'll cancel, and we'll get 7 over 7. That's going to be 1. So if you have v is equal to 1. All right? So 6v plus 1, right, that's 6 times 1 plus 1. That's going to be 7. Okay. So let's see. We should probably try one more of those, right? Let's see if they give us another one. Or maybe that one was too easy. No, this one is not nice either. I mean, it's not, when I say it's not nice, I mean, sometimes they'll be nice to you and they'll do something like 2x minus 4 equals something and then solve for x minus 2. Okay, well, I know this is just double. So, yeah, that's what I mean by a cutesy way, but they didn't do that for us. So we just have x minus 2. Solve for this, given that minus 2x minus 6 is equal to, what do we have here, 8. All right. So again, we're just going to solve for the x. We're just going to add 6 to both sides. Minus 2x is equal to 14. And then what we're going to do is we're going to divide both sides by negative 2 or multiply both sides by negative half. Okay, both will do it. So that'll cancel. We have x, 14 over 2, minus 7. Then we have to plug it back up into here and say, well, what's minus 7 minus 2, right? You're $7 in debt. You spend $2 more. Congratulations, you're $9 in debt now. Okay. So that's all they're asking you to do for this. Okay, let's go ahead and do that. And then let's do one more here. Okay, determine whether points lie on, given points lie on one or both or neither of the two lines given. All right. So it looks like we have two lines here. Okay, and they just want us to test these points in here to see if we get something that's true. Now, oh wow, they really, they want us to do the whole, they want us to be very detailed here. Okay, so we have 4x plus 3y is equal to 15. Let's see if that's true. Negative 10x plus 3y is equal to negative 27. So these lines are going to have different slopes. So there's only one point that's going to be true for both of them. But they really have us checking out everything that's here. So we're going to go ahead and we have to check everything because they want this whole matrix filled out of, is it one line or the other line, both or neither. Oh, geez. Okay, so 3, 1. Right? Remember, it's always x, it's always y. X is always first, y is always second. So this is 4 times 3 for my x plus 3, 1 for the y. And does that equal 15? Well, that's 12 plus 3. That's 15. So 3, 1 is at least on line 1. Okay, let's check over here. So this is negative 10 times 3 plus 3 times 1. Is that equal to negative 27? So that's negative 30 plus 3. That's negative 27. So this point, 3, 1, happens to lie on both of the lines. So if I could click on it, I would say both here. All right. What about the next point? That's 7, 5. Now, one can't lay on both lines because they, two lines are going to intersect, right, in one point. They're not going to loop around and intersect in 2 points. So I can get, well, unless it's the same line, but I think these guys have different slopes. Yeah, they have different slopes. Okay, so let's go ahead and figure that out. So we have 4 times 7 plus 3 times 5. All right, so we have 28 plus 3 times 5 is 15. There is no way that is going to be 15. So this is not going to lie on this line. It doesn't make a true statement. Okay, I don't even have to care about what 28 plus 15 is going to be. I know it's not going to be true. Okay, what about the other one? It could be, right? Just because it isn't here doesn't mean it can't be here. So we have negative 10 times 7 plus 3, right, times 5. That's a 3. So it's negative 70 plus 15. Does that look like it's going to be negative 27? Right, so you're $70 in debt, and you pay back 15 of them. Are you almost done? No, no, you got a long way to go. So not true for either one. Okay. How about the last one, 0, 5? Okay. So it's 4 times 0 plus 3 times 5. Is that 15? Oh, yeah, 15 is 15. We can do that. That's 0. Okay. I don't even have to check this one because I know it's not true. So that's 0. 15. 15 is not equal to negative 27. So that's not true. So it's just this one. It lies on this line only. This one was neither, and then this one lied on both. So that's what they want you to do with that problem. I know it seems a little bit long. It's okay. But and I would set it up to do this because you know, in the future you might be doing this with more points, or these might be more complicated. Okay, so I would just teach yourself to do things in kind of an organized manner this way, and in that way you'll be fine when it gets to be more complicated. All right. So that's see, that's all of those. So I got us all ready to learn stuff. We should be able to do some other stuff here. I'll wait. Today's Wednesday, isn't it? It's only Wednesday. I'll wait till tomorrow and see how far, if people get a little bit further along with some of the Alex stuff, to see if we get further into this. Okay. So we'll be all set. Okay, and since we're doing okay here. All right, so let me go ahead and do this. I'm going to go ahead and stop my video for just a moment because I want to go back, and I know if I go back, I'm going to end up revealing somebody's name, and I'd rather not do that. So give me just a moment. All right. And all right. So it turns out I wasn't going to do the name, but I'd rather be safe than sorry. So I want to, it's important to preserve your privacy there. All right. So this function, this point, 1.3, functions and relations. So we have to figure out like which is which and how do you tell. Okay. So I'm going to go ahead and we'll do a little bit of theory stuff for this, and then we'll go into what's going on with it. Oh, actually, you know, we could do this. All right. So how do you tell if it's a function? Okay, so functions map a set called a domain into a range. So this is the function part. It's the thing that's taking numbers from the domain or taking things from the domain and pushing them into the range. It's the rule that you follow. Okay. And all the definitions, all of the rules tend to go with the domain. Okay. So if I have a value here, right, we've got 0, 1, 2, 3, 4. And over here, we have 0, 1, 2, 3, 4, 5, 6, 7, 8. If I wanted to say, well, my function, right, is 2x, we're just going to double it, right? We would be able to map, right? Let's go ahead and give, we would be able to map, right? 0 twice 0 is still 0. Twice 1 is 2. Twice of 2 is 4. This would be 6. And this would be 8. Okay. This would be a function. And the reason why it would be a function is because everything in the domain has an arrow pointing away from it. Okay. The other thing is it only has one arrow pointing away from it. Okay. So everything in domain has exactly one assignment. Okay. So everything in the domain has exactly one assignment. If it didn't have an assignment, then it wouldn't be a function because not everything in the domain got used up. So if elements are left in the domain without assignment, then it's not a function. Okay. And if an element gets mapped to two things, right? If there was an element to two ranges, right? So if there's a domain element mapped to two range elements or more, okay, then it is also not a function. Right? So just to show you that it doesn't have to be with numbers. It's nice if it is, but okay. Over here, let's say here's a domain, here's our range, and we're just gonna do something like flutes and clarinet and trumpet, trombone, and then we'll do piano. In my range over here, right, we'll do woodwind and brass and string. If you ever took a music class ever, piano is technically a percussion instrument because you pound on the keys, and that's how the noise gets made. So it's not, even though it's technically when you do press the key, there's a little hammer that comes down and hits the string, but it is not considered a string instrument. It's a percussion instrument. Okay, so we could map the flutes to a woodwind and clarinet to a woodwind. Trumpet can go to brass. Trumpet can go to brass. Now, this is not a function because I never had a chance to map piano to any of these categories. Okay, so because piano is left off the list here, right? It's an element in the domain. Like where is it going? It's not doing it. Okay, so that's not a function because piano is left hanging. Okay. If we try another example that's very similar, okay, I'll still use that. Okay, so if we have our domain here, range, and this time we'll do flute, we'll do a saxophone, and what we do a tuba. Okay, and then a range again. We'll just do a little one here. We'll just say woodwind and brass. Okay, and a lot of people, a lot of kids when they first do this, right? They say, well, the flute definitely goes to woodwind, and tuba definitely goes to brass. And they look at saxophone and they're like, well, it's made out of metal, so maybe, but it makes its noise because it's a reed instrument. So we're going to do this. This one's wrong, by the way. Would not be a function because saxophone has two things sticking out of it, right? It has two arrows. It's not a function, okay? Because this can't get mapped to two things, all right? I'm going to go back to numbers for just a moment, and we're going to look at this. What does this mean as far as a graph goes? Because you don't always have to do all of this, okay? There are problems that do this, though, so just realize that, you know, you have to know the rules because they ask questions, okay? So what if we go back to some numbers, right? And I do 1, 2, 3, 4. And over here, we'll map things kind of to itself. We'll do 1, 2, 3, 4, 5. Okay. And I'm going to map 1 to both 1 and 2. Okay. Now 2 is just going to map to 2. 3 will map to 2, and 4 will map to 5. Okay. Look, what about this 4 here? There's no rules that says that everything in the range has to get mapped. We don't care. Okay. But here, 1 got mapped to 1 and 2. So we know it's not a function. But let me look at a graph and see what this graph would look like. So here we have 1, 2, 3, 4. No. And then we have 1, 2, 3, 4, 5. Because these are just dots, that's all they get. Okay, the one value things, they just get a dot. So 1 maps to 1, but 1 also maps to 2. 2 maps to 2, 3 maps to 3, and 4 map to 5. Okay, so because what happens here, right, there's something that happens, and we'll use pink again, that's fine, that you could put a vertical line through this graph and hit one of these points twice, right, to hit the graph twice on a vertical line, then we know it's not a function. So if I hand you a graph of something and you could pass a vertical line through it, then you know it's not a function. This is the, see how creative mathematicians are. Vertical line test, it's what it's called. Okay, this says nothing about whether or not it has a formula. There's some very pretty formulas that are not functions. Okay, all it says is, can we map a vertical line through it? Like, yes, it's not a function. No, it's a function. Okay, well, probably. As far as a graph goes, that's how we do it. Okay, so we learned circles, right? Centered at the origin, radius 5. Pretend that's round. And fails the vertical line test. Right? So because it fails the vertical line test, this is not a function. Okay. You can either have the upper half or the lower half, that's fine. But because it does both, you can't have it. All right. So not a function. But it is a formula. Like that's not part of the rules. Okay. A lot of time, that's one of the big things with the math classes. Well, it's a big thing with all math classes. So a lot of times students will look at something and they'll start imposing their own rules. Like, if it doesn't say it's a rule, it's not a rule. Okay. So just because, like, you know, if I gave you a function like this, it was just a bunch of dots, right? And I asked if it was a function. Well, the domain is kind of weird because it's these like points that are in here. So it kind of looks like one of these. But it's still, right? Does it pass the vertical line test? Like, yeah. So it is a function because the domain is going to be a list. The range is going to be a list. But, and it's okay. Hey, wait a minute. These two look like they go to the same. Like, yeah, that's fine. They could all go to 1. That's okay. Case in point, the school, the computer system uses a function to to assign students to a class. You are all assigned to this class. So all of the domain values, that would be you folks, all get assigned to this one class. So you can all go to the same place, that's fine. But 2 people or 1 person can't, well, in the before times when we had classes that were face-to-face, 1 person cannot be assigned to 2 different classes that meet at the same time. Okay. So this would be a function. He said, but you didn't connect the dots. I'm like, it's not a rule. Okay, it's not a rule. So the only thing that matters is, you know, do we have everything that's labeled here? Like, sure, you can't really tell that from the information, so we have to assume that you did. But more importantly, pass the vertical line test? Yeah. So not a function. Oh, wait a minute. Yes, this one is. Not a function. All right. So, oh, no, I still need a minus there. What am I doing? That still has to be a minus. All right. This looks something like this, okay? Right? Definitely not a function. Fails the vertical line test a lot of times. It's not a function. Oh, that was right. I got a minus here. Yeah. So not a function. All right. So you'll learn about these in pre-calc called hyperbolas. They're related to circles. There's the x squared and the y squared. Okay, it's just that they're not the same. One's plus, one's minus. You get hyperbolas. So if you're ever interested in finding something like that, if you ever get an urge to watch a cartoon about math, Donald Duck and Math Magic Land. They used to show us this in elementary school, like once a year. Um, they talk a little bit about stuff like this. Not in depth. They don't show you formulas, but they show you a lot of pictures. So 3 parts. It's on YouTube. You can watch that. All right. Let's take a look at your actual homework. Okay. Determine if the relationship defines y as a function of x. Well, does it pass the vertical line test? Like, yeah, it sure does. So yeah, this relationship is going to be fine. All right. Let's see what we have. So clearly, no, doesn't pass the vertical line test. I stopped asking questions like this on exams because I thought they were a little too easy for people. So they're, if I ever come up with one again, it'll be like one question that's really like 3, 4, or 5 parts. But there's one of these tricky examples, right? They all got mapped to the value y equals -2. So if I'm trying to get how much people owe me or something, or how, maybe I'm trying to figure that out, I could lump all the people that owe me $2. That would be nobody, but you could lump all the people that owed you $2 into one group, and they would owe you $2. You wouldn't owe me $2 and $3, right? This is all the people that just owe $2. Okay, so even though they're all mapped to the same thing, that's fine. It's still a function. When you map one person to $2 and $3, then you have problems. Okay, so that wouldn't work out. Let's see here. See, circle, right? They test you whether or not you can identify a circle. So that's why you have to remember this stuff. Okay. Line. Really, how much more are we going to do with this? Okay. Do they go into one more? That's it? That's all they... okay, there we go. All right. So here we have, okay, we have some function notation, and they're getting used to that, which is good because we're going to use that a lot. But we have h of x is equal to the square root of x plus 1. Okay, so I will tell you that on inspection, this thing is a function. They said evaluate the function. It really is. They're not trying to trick us here. If you ever look at a problem and you're like, well, that was obvious. Yeah, it's one way to say it, like obvious, but really what you want to do for your teacher, if you think it was obvious, just tell them by inspection the answer is. Okay, people, they'll look at you like, wow, you must be really smart. Some teachers will still sell you not good enough, but at least you use nice language to say so. So what I'm going to do here is if I say this is h of 3, that's how this is pronounced, right? This is h of 3. What this means is everywhere we see an x, we're going to put in a 3. Okay, so h of 3 is equal to the square root of 3 plus 1. All right, so that's just going to be fine. We're going to say that's 4. That's 2. So this ordered pair, right, the x would be 3, y would be 2. This gets a little tricky because sometimes they don't ask you for a number. They do h of a. And that's going to be the square root of a plus 1. Okay, so the rule is whatever you see in that x, you plug that in. Okay, and I know this is unsatisfactory as an answer, but I can't do anything more. Like, yeah, I know, it's just going to sit there and taunt you. Okay. What sometimes happens is that there's an expression in there. So they might put in like, you know, a plus 5. And this gets even worse because everywhere you see an x, right, we're just going to put in a plus 5 plus 1. And then you simplify it because pluses work this way, right? You say, great, that's all you can do. Okay, that's all we can do with that. So when you see this function notation, just realize, okay, it doesn't have to make any sense whatsoever. Right? Nobody's happy when they have to do this, right? Like, I don't even know what that means, but that's what the rule says to do. Okay, that's how you interpret this. I'm like, but that's nonsense. I'm like, yeah, it is, but that's how you do it. All right. So let's see here. That was 8. Let's see if we look at a couple more of these. Oh, see here, right here. They're taught this already. Okay. What this is used for, like why it seems like a lot to go through just to change the letter. Like, yeah, it does. And I really did think that when I first learned it. Like, why are you just doing all of this to change the letter? We want to get you used to doing this because there's going to be times where we're going to be talking about f of b minus f of a. And I want you to be able to realize, like, this is a function evaluated at one value minus a function evaluated at a different value. And I don't know what those values are right now, but I want you to know that they're different. And we're taking the y2 minus the y1, or the y evaluated at b minus the y evaluated at a. So we have k of x is equal to x squared minus 3x. Is that it? That's all they wanted? That's all they wanted. Okay. So, and this is another thing that this always got to me when I was, when I was in lower math classes. This bugged the heck out of me. I could not see this for the life of me, and I was much happier with doing this. And you know how much this helped me back? Never. So if you would rather write down this until you're ready to say it's this, that's fine. You'll be just fine. Okay. So if you're looking at this, like, because I was like this, it didn't bother me to evaluate stuff this way. Like, I can plug numbers in and like, okay, I get that. But if you asked me to graph it, like, my mind went right out the window. I did not see this as a graph. Whereas this I saw as a graph just fine. This I was happy with. This, graph it, like, I don't have an axis. I don't know. I had a big mental block with this one. So if it helps, you put that wherever, f of x, k of x, whatever. You make that a y. It's fine. Okay.
Mark?
Yes.
I don't really understand that. Is it kind of like the intercept? Why did you replace that with the y?
Because when I was doing this, I've always found it easier to look at a graph that looks like, well, if they give you the instructions, right? They give you those instructions. I always felt more comfortable graphing this. This means exactly the same thing. It's just a different way of writing it because this is using function notation and this is using like y equals mx plus b. This is just using x and y. But this y is this kx. And it's just a different way of saying it. That's all it is. Does that make sense?
Yes, thank you.
I'm kind of hoping, because when I was sitting in your chairs, this did not make any sense whatsoever. I was like, why are you doing this to me? I like this. It's because later on, they're going to want to do things like k of 0, k of 1, k of pi, k of 10. They want to be able to write this down and just have people understand this, not when x equals 0, y equals what. Okay, so it was just an easier way to say this. But they do mean exactly the same thing. All right. So they want, okay, what is k of b minus 5? All right, well, what does the rule say? The rule says everywhere we see an x, we're going to replace it by b minus 5. All right. Now, they probably want us to, see, I'll try. I'll be mad if they let me get away with this, though. Oh, they don't even let you use the parentheses. Okay, well, I guess they're not going to let us get away with it. Good. So what they want us to do now is we have to untangle this knot. So we have to do b minus 5, right? And then FOIL this thing out. So that's our first, that's b squared. We have a minus 5b, we have another minus 5b, and 5 times 5 is going to be 25. But since they're both negatives, we end up with a positive here. So we have b squared minus 10b plus 25. Okay, so that's what this part is. And then we have to deal with this. But remember, this is really a plus negative 3, right? There's a better way to think about it, because when we go through to multiply this out, I don't want to have to keep track of that negative sign. So this is going to be negative 3 times b, so that's negative 3b. And we have negative 3 times negative 5, and that's going to give me a plus 15. So to simplify this down, we have a 1b squared. We have minus 10b's minus 3b, so that's minus 13b's. And we have 25 and 15, and I think that's going to give me 40. That's the answer they're looking for this. Okay, so they gave us this, and then they said you gotta combine this. Now, I don't know what the to relate this to a real problem. The 13 here would probably have units on it. So these would all have units. So right now, without that, right? So we can add these if they had numbers in them. But right now, you're adding an area to like a length to a number. And you don't really want to do that. Okay. So if we put numbers in here, we're just going to assume that the units work too, and we get something. But if it helps you think about, like, I can't add these because we have an area, a length, and a value. Can't do it. Right. We put numbers in, that's fine. But until we put numbers in them, you got nothing. This is what you have. Okay, you have this mess. So I noticed that's a lot of things that's a mistake that people make, is to do that. Minus 13b. Again, if you push forward, if you're up here with the exponent, you push forward with the arrow. So I think it's a minus, wasn't it? Oops. 13. Someday I'll get around to joining the 21st century. All right, and that's what they want. All right. So let's see here. All right. How many points? How many values do we have? We just have one. Okay, we're not going to worry about that. That one looks pretty tame. Okay, this is another one, kind of like the same one we just did. Okay, you're going to see x plus h a lot. Find x plus h. So I'll tell you about the h, because they use this notation all the way through calculus. All right, and here's our f of x is equal to negative 2x squared plus 6x minus 2, or minus 6 rather. Now, you don't have the context that this is going to be working on just yet. We'll get there, but you don't have it just yet. This thing is used for here's x, and they say here's x plus h. All right, where we have some value, and then we're going to move forward a value. Okay, and then this value here, right, is the difference. It's x plus h minus x. We can cancel that and say that that's h. Okay, this came from what they used. If you've ever found a math book from like the early 80s or the 70s, 1970s or before, they're not going to call it h. They're going to say that's x plus delta x. So it's it's x plus a change in x, right? So this value here would be delta x. And usually they use it for like a small change. So if you're measuring carpet and you're off by a little bit and your carpet doesn't quite fit, that would be your delta x. Okay, the mistake, the error in your measurement is usually what they consider that. But somewhere around the mid 80s, they decided that delta x was too difficult, so they made it easier and they called it h. Okay, I still think delta x is probably the way to go. I'm not old enough to have seen this very often, but I do have some books that are, older than I am, and that's what they did. So let's go through and see what happens here. X plus h, and that's equal negative 2 x plus h squared plus 6 x plus h minus 6. Okay, now the way I go through these is I try to do one thing at a time, where I'm just going to do one piece. So the first thing I'm going to do is multiply out the squared part here. So x plus h, and then we'll have x squared plus 2xh plus h squared. And then finally that one, right? So that's foiling that out. So we have negative 2 x squared plus 2xh plus h squared plus 6 x plus h minus 6. Say, wait, why didn't you do that? I'm not there yet, okay? Because I noticed that, and I make this mistake too, okay, that people, they get so excited they did this part that they forget to do that. So if I just do all the distributing on one line, I tend not to make this mistake. So minus 2x squared minus 4xh minus 2h squared plus 6x plus 6h, and then this guy's just back here for that. Okay, so 2x squared. I don't really know. I know, sorry. We have a cat that has heart conditions, so she cannot ever get, she cannot have the operation that she needs to have, which is going to make her not go into heat. So every once in a while, she gets real vocal. Okay. So heart condition, it's going to be problems if she goes under anesthetic. It's going to be problems if she gets pregnant. So we're, in both cases, it's going to be a good time. So we can go through and plug this in. So there's nothing to combine here, right? We're just kind of stuck staring at this mess. And then let's say, boy, that looks delightful. Like, yeah, I'm afraid so. So we have negative 2x squared, right, minus 4xh plus, was that a 2h squared? Minus 2h squared, right? Let me double check my values over here. Oh, these are all minus. Okay, oh, they're all, okay, we're good. Okay, and then plus 6x plus 6h plus 6x plus 6h, and then finally minus 6. And there we go for what they want us to do here. Oops, please fill in all the empty box. What is going on? Oh, let's make that a minus. All right, that's what they want. Okay, so I guess what we're going to do tomorrow is we'll go through a little bit more of this, but I'll probably be ready to go. We could try. We might push a little bit. I'll check. Oh, we're definitely going to go through some of this then. Okay, for word problems, we're going to go ahead and hit this. Okay. Yeah, this is all stuff that's good. We'll do this. Okay. So tomorrow we'll continue with this section 1.3, and I'll go through our Alex stuff and say what are we still working on. But if you're stuck somewhere, let me know. We can hit that. Okay, we can certainly cover the stuff where you're stuck. Okay, but we'll continue this section until at least we get through walking you through the word problems and some of the weirder stuff that looks like this.
Thank you.
So yeah, this is definitely we need to we need to talk about this. So we'll still do 1.3. All right. So thank you too, and we'll go ahead and stop.